we are doing radicals. Alright, so these are things with square roots and cube roots and whatnot. So, radicals. Alright, so the first key to this chapter is that we are doing everything exact. Now you can use your calculator to help, but you should not be getting decimal answers or anything like that. So we're going to start with a really simple thing. What's the square root of 100? 10. Alright, so now we're going to figure out, well then using that, what is the square root of 200? And here is one way to do it. And the way I'm about to do this is the shortcut way, and then I'm going to have to show you, some of you will need the longer way. That's fine too. Alright, so what I'm going to do to this is I'm going to split it up. I can't do the square root of 200 exactly. You can verify by putting it into your calculator. It will give you a decimal. But do you see that I can rewrite 200 as 2 times 100? Okay, so now I can rewrite that as square root of 100 times square root of 2. Well, what's the square root of 100?
10.
10. And what's the square root of 2? Well, I don't know. And this is my exact answer. Okay? Because I can't do the square root of 2 exactly. Let's try another. And I'm going to show you the shortcut method I would say 2 more times, and then we'll spend the rest of class on the way that is a little bit longer, but is actually going to work when you have really big numbers or something strange. So let's say, what's the square root of 49? 7. Okay. Let's see here. What do I want to do to you? Let's say, hand me your calculator. Thank you. Okay. Square root of 147. Alright, now you probably don't see this right away, but you would go through, if I'm doing this the quick way, what I would do is I'd do 147, I'd go through my perfect squares. Well, what are my perfect squares? Well, 4 is 1 because 2 squared, right? 3 squared, so 9 is a perfect square. 4 squared, so 16 is a perfect square. Do you see how I get my perfect squares? 5 squared is 25.
You put 12 and not 16.
My bad, 16.
You said 16.
36, okay, 7 squared, 49. Okay, so there's my hint right here, 49. So I might say, well, what's 147 divided by 49? Use your calculator. And Rachel is saying 3. So I could rewrite this as 49 times 3. Now, why would I want to do that? Well, because I can actually take the square root of 49 exactly. And the square root of 49 is 7, but I cannot take the square root of 3 exactly. So I'm going to show all the steps here. I do 49. So you see how I split that square root up into 2 parts? And I take the square root of the 49, the part I can't exactly, and that leaves me with square root of 3. Is anyone completely lost on how I did that? Alright, let's say I had square root of 45. Now this time I'm not giving you a hint by doing a square root first. We need to figure out, well, what is the perfect square that is a factor of 45? Hopefully you think of, what are some factors of 45?
5 and 9.
Okay, so 9 and 5, are one of those a perfect square?
9.
Yes. So 9 times 5. Do you see how I split that 45 up into 9 times 5? And now I split that to root 9 times root 5. And what's the square root of 9?
3.
So I have 3 root 5. Do you see how I did that? If you can identify the perfect square, that is the fast way to do these problems. Okay? But not every problem is so simple. Okay? So let's try a difficult one. Let's try, square root of 120 x to the 5th y to the 8th. Okay, so now we have some variables in the mix here. Now, you could probably figure out the perfect square that is a factor of 120, but in this example, I'm just not going to do that. I'm going to do it a different way. So the first thing I'm going to do is I'm going to prime factorize. I'm going to prime factorize the 120. So when I prime factorize, I can think of any two factors of 120. In this case, I'm just going to think of 10 and 12. Do you see where I get that?
Yep.
But I could do 2 and 60. I could do 3 and 40. It doesn't matter. And I just keep on going down until I have all primes. And you might get there a different way than someone else. I bring down everything. And now I'm going to say 120 equals 2 cubed times 3 times 5. Do you see how I did that? So down here, I want you to just keep this in mind. What's the square root of x squared, do you think? X. X to the 1. What do you think the square root of x to the 4th is?
X2 squared.
I don't know why that happened. Go back. Did I delete that?
Probably did.
I didn't mean to do that. Undo.
That's not good.
Undo. Yeah, I don't know. I don't know why. Where'd it go?
Just a double leaper.
How many subscribers?
Alright, I don't know. Trey, knock it off. Alright. I guess I'll just start that one over. So we had square root of 120 x to the 5th, y to the 8th. We prime factorized the 120, and what did we get?
10 and 12.
What?
Oh, it thinks I'm trying to cut. Control. It's all messed up. Oh well. Alright, so we had 2 to the 3rd, what?
Times 3 times 5.
Times 3 times 5. Okay. And then I was talking about what is the square root of x squared? X. What is the square root of x to the 4th?
X squared.
X squared. What do you think the square root of x to the 6th is? X to the 3rd. What about square root of x to the 10?
X to the
Yes.
4.
5.
5. What am I doing to the exponent?
Dividing and adding them.
Oh.
Adding up a line.
Wait, I thought you...
Okay, let's do one more. Square root of x to the 16.
8.
X to the 8. What am I doing to the exponent?
Dividing
Dividing it by 2. Because look, if the index is not written on a root, it's a 2. So whenever I'm doing these, let's say this is my index. I'll call it n. And I have x to the a. The answer is x to the a divided by n. That's what that turns into.
So if the index isn't there, it's always going to be 2?
Yep. So it's kind of weird. Sometimes when something isn't there, it's a 0. Sometimes when something isn't there, it's a 1. And sometimes when something isn't there, it's a 2. And the reason it's a 2 is it wouldn't make sense to take the first root of something. Anyways. So, what I need, so I'm going to replace that 120 with 2 cubed times 3 times 5 times x to the 5th times y to the 8th. Now, I'm going to divide all those exponents by what number?
2.
2, because that's my index. But I can't, take a look, divide all these things that I'm underlining by 2, because what's the exponent on the 3?
1.
Okay, so I can't divide those by 2. But from our rules of exponents, what would be 2 squared times 2 to the 1? What do I do with my exponents? Add them. And I get 2 cubed, right? So I'm going to erase all this stuff. So what I'm going to do is I'm actually going to work that backwards. I'm going to say, well, I need this to be divisible by 2. So I'm going to split 2 cubed up into 2 squared times 2 to the 1 times 5. I skipped 3, so get the 3. Now take a look at this x to the 5th right here. I need to split that up too. Now I can split that up to 2 squared times 3 cubed. That's not so good. I want to count backwards from 5. I want x to the 4th times x. I need these divisible by 2, so I split that to x to the 4th times x to the 1. And the y to the 8th is fine. Now all the ones that I'm circling, I can actually do the square root of. All of these we can do the square root of because they're divisible by what?
2.
2.
Why is y to the 8th fine?
Because you can divide
Because 8 divided by 2 is 4. Okay, so the square root of 2 squared is 2. What's the square root of x to the 4th?
x2.
X squared. And the square root of y to the 8th is
4.
y to the 4th. Then, left on the inside is all this stuff that I'm underlining is what's left. So 2, I'll put the 3 in the right spot this time, like this. And now I'll multiply that out on the inside. So once you take the root of something, notice that it comes on outside. And this is our final answer. So there's a lot of steps to get there. And I don't know why this says I want to cut. Maybe if I do edit. Oh, well, that says that's in control. I don't know why it says control. It's making me mad.
Maybe a sticky key.
Maybe I do. Sticky key. Alright. Go on.
No! Why would you do that? I'm not. Dang it. Did you do
Maybe if
that?
I turn this on and then off again.
If you get that
Or off and on again. Okay.
I
Oh
thought it was
well. Whatever.
good.
Alright, we're going on. What if I had cube root x to the 7th, y to the 12th, z to the 16th. Now my index is not a 2. And let's go ahead and write this down, the parts of a radical. The thing right here, above the little hump, that's our index. That's the roots that we're taking. This whole symbol is called the radical. And this thing on the inside is the radicand.
What?
Radicand.
Are you serious?
Yes. Alright, so. Trey. Stop. Well, I get to write really small now. Alright, whatever. Okay, yeah, I don't like that. Alright, anyways. I need these all divisible by 3. So I'm going to have cube root. I'm going to rewrite this x to the 7 as what do you think? X, what will be the first index?
4.
Or exponent.
No, would it be 4?
I need it divisible by
6.
what number?
6.
I need it divisible by 3, so it's going to be a 6, and then the other one will be a 1.
That's even better.
Okay? Y to the 12th is fine, but what about z?
You change it to 4.
15 and 1.
15 and 1.
So good.
Alright, so cube root. Now, all the things that I'm about to circle, I can take the cube root of, fine. Everything else, I cannot take the cube root of. So what's the cube root of x to the 6th? What am I going to do with that exponent?
Divided by 2.
Divide it by 3 and get 2. Y to the 4. And then z to the, then cube root, don't drop the cube. What's left on the inside?
X and Z.
X and z. Now a common mistake that students had last year was they would leave things in the radical that they'd just taken the root of. They come out when they're done. I'm going to try to increase it. Oh, gosh, I didn't want to do that. Well, now I can't undo it.
Wow.
Oh gosh.
What a
Why
guy.
is this stuck?
Oh my gosh.
Mm. Wow.
Alright, there. One way or another, I'll get there. Okay, next one. Alright, so let's say I have 5 roots. Let's do 12x cubed times 3 root 6x to the 5th. Here's what I'm going to do. As long as the indexes are the same, so write this down. If the index is the same, I can multiply. Now, you can decide whether you want to prime factorize before or after you multiply. I'm going to decide to prime factorize before I multiply. Okay? So I'm going to prime, yes, I'll have to do it twice, but it'll be smaller numbers. Do you see what I'm saying? So if I prime factorize the 12, this is what I get. And if I prime factorize 6, this is what I get. You with me? But if you want, you can do it after you multiply. It makes no difference. So how am I going to multiply this? Well, I'm going to take all the things in front, and I'm going to multiply them. So 5 times 3, 15. And all the things on the inside, I'm going to multiply. But this 12 is going to be written as 2 squared times 3. Do you see where I get that? And this 6 is going to be written as 2 times 3. Now, what's 2 squared times 2?
8.
It is 8, but I want to do it in exponential form, so what's 2 squared times 2 to the 1? Using rules of exponents.
2 to the third.
2 to the third. And what's going to be 3 times 3? Yes, it's 9, but use exponents.
3 to the 2.
3 what?
Squared.
Okay, and then using rules of exponents, x to the what?
8.
8. Okay?
But you get 8.
Now, I need to split those exponents up so they're divisible by what number?
15.
2.
2. Because my index is 2. The index is the little thing above the hump. The 15 is the coefficient. It's in front of that. Okay, if the index was a 5 and this index is 3, then I couldn't multiply them because their indexes would be different. So I need to split these up so they're divisible by 2. Alright, what's the square root of 2 squared?
2.
Okay, so I'll have 15 times 2 on the outside. So I've done that. What else can I do the square root of?
3 squared.
3 squared. What's the square root of 3 squared?
3.
So I have a 3 on the outside.
And 8.
And square root of x to the 8th is x to the 4th. That leaves root 2 on the outside. Now I'm going to simplify, or on the inside. So I'm going to simplify this, and I have 15 times 2 times 3, which is going to be 90 x to the 4th root 2. Okay, the last thing would be dividing these. So we'll talk about that here. What if I'm dividing them? Well, let's say I have the square root of 17 over 144. The first thing I'm going to check for is if I can simplify. Okay, could I simplify 17 over 144?
No.
Is 144 divisible by 17? Use your calculator and check. Is it?
No.
No, it is not. Okay. So if it is not, then I'm going to do this. I'm going to do square root of 17 over square root of 144. Can I do the square root of 17?
No.
No. All right, so that stays the same. Can I do square root of 144?
Yes, you can.
And it is
12.
12, and I'm done.
That's it.
That's the answer?
Wow.
Yes, we're done.
Wow.
Okay. Next one. Let's say I have square root of
3.
8 over 64.
Yeah.
Now there's a few different ways that I can do that, but the first thing I'm going to ask is, can I simplify this? And the answer is yes. I get square root of 1 over square root of 8. Now I split it to square root 1 over square root 8. Now here is the fact that makes us very sad. We cannot leave radicals in denominators. We cannot do that. That is not allowed. So, at this step, there's a few different things that we could do. We could simplify the square root 8. So square root 8, the perfect square in 8 is 4. So I could simplify square root 8 to 2 root 2. Alright, that's one way. And that's not wrong, we could do that. But it's going to be a little bit extra work. We're going to do a trick. Here's our trick. Square root 8 over square root 8 simplifies to a 1. And so I'm basically multiplying this fraction by 1. Okay? It doesn't look like a 1, and nor is it going to turn out that way. Square root 1 times square root 8 is square root 8. And square root 8 times square root 8 is square root 64, and you're like, well, then you're back to where you were. Yeah, I am. Because we probably should have just done, you see how this is a perfect square? It's perfect the way it is. So sometimes simplifying actually takes us around in a circle. If I can do a perfect square, I do it. So what's the square root of 64?
8.
8. And that leaves me to square root 8 at top. And then I just simplified square root 8 right there. So that would be 2 root 2 over 8. Do you see this part right here? I can simplify that. I'm going to do it in red up here. I get root 2 over 4 because the 2 and 8 cancel. Now you might be thinking, wait, could I cancel this root 2 with this 4? No, because the 4 is not in a radical. Now I know that was a lot of stuff right there, so we'll do one more of those. Okay? Now I'm going to, are either of these perfect? Perfect squares? No. None of those are perfect squares. So, it is easier to simplify. Can I simplify root 60 over root 12?
Yeah.
Yes, root 5, right? Done. How did I do that? 60 divided by 12. Okay? Alright, but what if I had this?
Maybe,
Now when I simplify, what's on top? 1. What's on bottom? Square root 5. I cannot leave a square root 5 in the denominator. So I'm going to multiply by root 5 over root 5, which equals root 5 over root 25. What's the square root of 25?
5. Yeah, what do you use this for?
I'll talk to you later. All right, root 48 over root 8. Can I simplify? First, are there any perfect roots in here? Yes or no? Can I do the square root of 48 perfectly?
No.
Square root of 8?
No.
So then I simplify. What's, you see that simplifies to root 6? Over 1, which is just root 6. What if I had 3 over root 6? This would be the last example. I can't leave a radical down there, so what am I going to multiply by?
Root 6, root 6.
Root 6 over root 6, which equals 3 root 6 over 6. I'm not done. Can I cancel those?
Yes.
Yes, so I do. So our final answer is root 6 over 2.
Wait.